When we add or subtract rational expressions with unlike denominators, our first objective should be to create a common denominator so that we can actually add or subtract the expressions. Looking at these two denominators, we have a denominator of 5x and a denominator of 6x. If they were just 5 and 6, their common denominator would be 30. Because of the presence of the x in each one of them, when we reconsider the common denominator, we're just going to tack on an x to the end. These situations where you have two monomial divisors, two monomial denominators, it's really simple to come up with the common denominator. So you do it for the numerical part, and then you do it for the variable part. Changing both of those fractions into denominators of 30x, we're going to multiply the first fraction by 6 in the numerator and the denominator to get 72. And we're going to multiply the second fraction by 5 and get 35 as the numerator of the second fraction. Subtracting the two of those, we get 37 over 30x. 37 and 30 share no common factors. 37 is prime. 30 has some factors, but none of them are shared with 37. So we have a final answer of 37 over 30x. In our next example, we have two binomial denominators, two binomial divisors. We'll use a similar technique of examining both of the divisors and then creating a common denominator. We need both of these factors, the x plus 4 and the x plus 6, to appear in a common denominator. So our common denominator is going to be those two factors multiplied together. Creating two new fractions. Our first fraction will get the factor of x plus 6, and our second fraction will get the factor of x plus 4. Our first fraction multiplied by x plus 6 in the numerator and in the denominator creates a 3 times x plus 6. And our second fraction multiplied by x plus 4 in the numerator and the denominator gives us a factor of x plus 4. As we move to the next step and we combine these two rational expressions into one, we want to be very careful when we do the multiplication and the combining. It's very easy to forget that that minus sign needs to subtract both of the terms in that binomial. So while the first part comes out to be 3x plus 18, we need to make sure we say minus x minus 4 for the binomial from the second fraction. Cleaning up the numerator, we're left with 2x plus 14 over x plus 6 times x plus 4. And notice that we're going to leave our denominator factored. We're going to factor our numerator into 2 times x plus 7, and we're going to check those two factors against the two factors from the denominator. Obviously, there are no equivalent factors in the numerator and the denominator, so that is our final simplified version of that difference. We're not so worried about the fact right here that we wrote this backwards. As long as we come down here with the same factors in the denominator, we're good to go for the simplification that might happen in that last line. In our last example, we have two seemingly very different denominators. We have a trinomial of the second degree and we have a binomial of the first degree. However, a careful look at the trinomial from the first polynomial, or excuse me, from the first rational expression, this denominator is actually x plus 7 times x minus 2. That factor matches the x minus 7 from the second parentheses. So when we write our common denominator, there's no need to include it twice. We include it once for showing up in each of the denominators, and then the x minus 2 for showing up in the second denominator. We're going to change both of our fractions so that they have this new denominator of x plus 7 and x minus 2. Because the common denominator matches the denominator of the first rational expression, the numerator will just stay the same. We don't change that first fraction at all. The second fraction will need multiplied by x minus 2 in both the numerator and the denominator. And we can write it temporarily as x plus 3 times x minus 2. Combining these two together, thanks to their common denominator of x plus 7x minus 2, we have x squared minus 5 from the first rational expression, and then x plus 3, x minus 2. We want to be very careful about the way that we write this. Notice the inclusion of the brackets. We want to make sure we're subtracting everything that comes out of this multiplication here when we're done. X squared minus 5 minus the entire x squared plus x minus 6, the result of doing that multiplication that was inside of the bracket. Again, keeping the same denominator. We clean up our numerator, x squared minus x squared, simplify to 0. Negative 5 minus negative 6 simplifies to 1, and negative x is a term that's still there. We keep our denominator. We check to see if anything in our denominator matches the factor from the numerator. We consider this as its own factor. We could even imagine taking the negative 1 out and writing it like this if we were going to look for a common factor, get some opposites going. But still, with the presence of the 1, the 7, and the 2, there's nothing there. And our most simplified version is what we have right there. So, general point of the conversation. If you have two rational expressions that you're trying to add or subtract, you want to make sure you're pursuing the common denominator first, changing those fractions so that they meet that denominator, and then combining as you would with any polynomial subtraction. Not worrying about the denominator again until you get to the bottom, checking to see if those factors that are created in the denominator simplify with any of the factors from the numerator.